Temperature. It's one of those things everyone thinks they understand. Hot means fast, cold means slow, but few people ever stop to realize what it actually is. In scientific terms, temperature is a measurement of how much kinetic energy the particles in a material have on average. In normal words, it's how violently stuff jiggles. The faster atoms and molecules shake, the hotter the material becomes. So, if you could somehow convince every particle in existence to stop moving completely, you'd have the lowest possible temperature, absolute zero. Absolute zero is like the universe's version of nah, I'm done. It's the point where all motion stops, all energy disappears, and basically nothing happens forever. Except, it can't actually happen. Every attempt to reach absolute zero just gets you frustratingly close. The colder you go, the slower things move but never fully stop. It's like chasing your Wi-Fi signal in the basement. Always, almost there, never quite enough. So, if cooling things has a hard limit, what about the opposite? What happens when you add energy instead, when you keep turning up the cosmic stove dial? At around 0.01 degrees Celsius, we reach the triple point of water, that magical zone where ice, liquid, and vapor all coexist. At 20-25 degrees Celsius, that's what scientists call room temperature, or as gamers know it, GPU overheating season. By 100 degrees Celsius, your water is boiling, and any remaining teabags have sacrificed themselves in the name of science. Raise that to 600 degrees Celsius, and you're at the heat of a typical campfire, or, according to internet temperature scales, 1 Natalie Dormer symbol, ND. It's roughly the point where wood burns and people start making questionable survival choices. Now crank it up. At around 10 ND, you've hit the Earth's core, also comparable to the surface of the Sunday. At 24,000 ND, you're inside the sun itself. That's hot enough to make hydrogen fuse, and your marshmallows spontaneously turn into plasma. In 2012, scientists at CERN decided to one-up the Sunday. They used the Large Hadron Collider to recreate temperatures not seen since the early universe by smashing heavy ions together. The result? 9 giga ND, or 9 billion Dormers. That's the highest temperature ever achieved in a laboratory, equivalent to roughly 5.5 trillion degrees Celsius, a number so ridiculous it sounds made up by a physics major on no sleep. The scientists called it quark-gluon plasma, the same kind of ultra-hot matter that existed microseconds after the Big Bang. Everyone else called it reheated hot pocket. The unit stuck. From then on, physicists began using the HPP hot pocket potential to describe unimaginably high temperatures. Jump a bit further, around 180 tera HPP, or 180 trillion hot pockets, the universe was just 10 to the power of negative 35 seconds old. That's so early that time itself hadn't figured out how to behave. Imagine every atom, star, and future meme crammed into something smaller than a proton and then rapidly exploding outward because reality couldn't handle the pressure. Energy, space, and logic all melted together into one giant what the hell. But there's an upper ceiling even beyond that, a theoretical limit called the Planck temperature. About 1.42 times 10 to the power of 32 Kelvin, or 142 nonillion degrees. At this point, matter doesn't just melt, physics itself gives up. Gravity becomes as strong as the other fundamental forces, and space-time turns into quantum soup. It's the do not enter sign of the thermodynamic universe. And yet there's always that one physicist who looks at a cosmic boundary and says, yeah, but what if we go 1 degree higher? That's where the concept of P+1 comes in, Planck plus 1. It's not officially recognized, but let's be honest, we've named dumber things in science. My personal proposal? I call it MNMT, maximum nuclear measurement temperature. It represents the point where even the instruments measuring temperature have melted into their own energy fields. Or, to put it simply, it's the point where the thermometer resigns. So, to summarize, 0 means everything stops. Planck means everything breaks. And MNMT? That's where the universe looks at your experiment and says, congratulations, you played yourself.